So today I'm going to discuss electricity a little bit, some magnets, and then circuits as well. But before I do that, I want to go over some housekeeping information again. I like to do this every time to keep you in the loop um, with what's going on. So our dates, we have November 8th, that's tomorrow. Can't believe it's already November. Everyone will be is going to need to turn in their electromagnetic radiation and optics test. I reviewed for this test last week, and if you go to the course resource newsletter for this module, you'll see that I actually have like lots of reviews posted for this. Some of them I did last semester, but it's all the same information. So definitely take advantage of that stuff. And if you watch the review from last week and you do the ELO that goes with it, you'll get an extra point on your test. So that's kind of handy. On November 15th, this is our last week before Thanksgiving. Everyone will need to turn in their electricity and magnetism test. And that's what I'm going to review for tonight. And then the week of November 20th through the 24th is Thanksgiving. So there's nothing due that whole week. You're not required to do anything. Even if your regular school is in session, like Monday and Tuesday or Monday, Tuesday, Wednesday or something, that week we don't have anything. This is a great time to work on test corrections or get ahead or watch those ELOs from the other, from all of the units. So hopefully, if you are in school that week, and I know a lot of kids have like a specific virtual school time, go ahead and do some of those test corrections or ELOs or something like that during your virtual school time while you're still in school. That'll just make it a little bit easier and a little less things to do when we come back. Because when we come back from Thanksgiving, it's like full steam ahead for like 2 weeks and then we're done. So there's a lot to do after Thanksgiving. So November 29th is our first due date after Thanksgiving, and there are no tests due that day. That's a Wednesday. But that week is our very last week of full content. So that Friday, December 1, you do have a due date and you do have a couple things due. So your nuclear physics test is due that day. So I know that's kind of weird. So please pay attention to that on the syllabus, okay, and on the schedule. And then Tuesday, December 5th, is the last day to turn in any missing work, that's eligible to turn in, like the stuff from Friday. And yellows, anything like that, test corrections, anything like that. I can't take anything after December 5th at midnight, and that is virtual school policy. Okay, so don't email me December 6th and say, oh, can I take my test corrections? No, I can't. All the Dropbox folders will close. Everything's going to close December 5th and basically December 6th at midnight. And we won't be able to submit anything, and that's a virtual school thing because December 6th and 7th is the final exam, and that is the only 2 days you get to take the final exam. Okay, that's a Wednesday and a Thursday. Okay, then the course closes December 8th, which means at basically at 11:59 December 8th or midnight on December 9th, you guys will completely lose access to the course. You won't be able to get into the course again. If there's anything that you need from the course, you want to print your feedback or whatever, you've got to get that before the course closes. And I am not allowed to grade your final exams until December 9th, that Saturday. Okay. So please email me December 7th and say, I took my final exam yesterday. Can you grade it so I know what I made? Or email me on the 8th or whatever. I'm not allowed to. Okay. I'm not allowed to grade those tests until Saturday. It's a core security issue. It's kind of like when you take the EOCT or milestone, you take the test and then you get your grade for it later. But they don't, tell you all the questions that you miss. It's that same kind of concept. So just kind of keep that in mind, that I won't be able to grade those for you till after the course closes. Okay. And then I wrote in here somewhere. Here it is. The dates of our final exam reviews. So next week, I'll be reviewing for the 1D kinematics test, the 2D kinematics, and Newton's laws on November 28th, which is the week after Thanksgiving. I'll be reviewing for application of Newton's laws, energy, momentum, the first half of waves. And December 5th, which is the day before the last day you guys have to do anything, but it is a Tuesday. I'll be doing the second half of waves, electromagnetic radiation, electricity, and the nuclear physics test. Now, there is an ELO for each of these, and it's a pretty awesome one. If you watch the review, you can attend live, you can watch the recording, and you answer, including your work, the question from each test covered during the review. It's in the ELO. They'll have a question from each unit or module that I covered. I will add 1 point to each of those tests. So for example, if you answer the 1D kinematics question, I'll give you a point on your 1D kinematics test. If you answer the 2D motion question, I'll give you a point on your 2D motion test. If you answer the Newton's laws question, I'll give you a point on your Newton's laws test. But if you just do the 1D kinematics one, I can't give you points on the 2D motion or the Newton's laws because I can't give you points on a test unless you've done something that relates to that unit. So that's why there's a question for each one. Okay, so that can be a great way to just, add a little cushion to your grade or bring up your grade right before the final. And then that's basically how the ELOs for the other ones work. So for example, there's an ELO for this review. If you go to the ELO folder and you go to the electricity and magnetism synchronous session, there'll be a question in there from something I work out today. And if you show that work and you work out that question, you can get a point on your electricity test. And you can do this for every single test, including ones in the past that you've already done. Okay, so not only can these ELOs bring up your grade, but they can also help you review for the final exam, which is the point. Okay, so excuse me, I have a little bit of a cough today. The big thing with the December 5th one is it's recorded on December 5th, and that's the last day to turn in. So it'll be recorded that day, and then you must do the ELO for it that day. Okay. Must be done the same day. And that's just kind of how things worked out with the session on Tuesday and, the last day to accept anything being that same day. There's not really a lot I can do about that. And so what I did for these reviews, just so you kind of know what to expect for them, I went into the test and I looked at the questions that were the most missed. And I'm basically going to go over the questions that were the most missed. So hopefully that will help you with those concepts that were most missed. And then, those specific questions as well. If you want specific, like detailed content information from, say, like the 2D motion unit, I would go back and look at the synchronous session recordings from the 2D motion unit, because that's going to, be a little more in depth, because I think there's 2 from that unit. So, that's 2 hours of really discussing that unit, where on November 14th, I'm going to be discussing, 3 units in 1 hour. So that's a lot, a lot less time per unit. So it's not going to be as detailed, but it is going to go over those concepts and those questions that were most commonly missed. So hopefully that will be helpful for you guys. I've heard doing this is helpful in the past. Students have told me it's been helpful. So it's kind of the plan. Now let's discuss the electricity unit. This unit, we're going to discuss a few things. And so let's just get started. So for this section, this formula is your Coulomb's law formula, and K is a constant, and I wrote it down here. You shouldn't have to memorize that. You can write it on your formula sheet, whatever you want to do, but you don't have to memorize that. It's a constant. The F obviously stands for force. The Q is a charge. Okay, so this would be like charge 1 and charge 2. And then there is a distance, and the D has to be in meters, and the Q has to be in coulombs. So for example, if they give you something in like, sometimes you'll see like a little MC, you'll have to convert that to coulombs. Okay, the Q has to be in coulombs. Okay, so that's the Coulomb's law formula. Now let's try this practice problem. So let's see. Okay, so we have 2 spheres that have identical charges. Okay, so this means that Q1 is equal to Q2. Okay, they're exactly the same, and they are 75 centimeters apart. This is our distance, but we're going to have to convert it to meters. And then it says the force is a positive 0.3 newtons, and then it says what is the magnitude of the charge on each sphere. So we're looking up, trying to figure out Q1 and Q2. And remember, they're the same. So what do we know? We know that our distance is 75 centimeters. And I'm going to go ahead and convert that to meters before I forget. So we get 0.75 meters. And then our force is equal to 0.3 newtons. And our Q1 is equal to Q2, and that is something in coulombs. And then our K is 9 times 10 to the 9. Okay, so here's my formula. Now what I'm going to do, since Q1 and Q2 are the same, I'm actually just going to write this. I'm just going to write Q1 twice, just because it's a little easier. And then anything, times itself is just is squared, right? So I'm just going to write Q1 squared over D squared, okay? And that simplifies the formula a little bit. Okay, so now I can go ahead and I can write what I know. So I'm going to write 0.3 equals 9. Yeah, I'm going to write it like this because that's how I'm going to put it in my calculator. And then I'm going to put Q1 squared over 0.75 squared. Okay, so that's going to give me 0.3 equals 9 e to the 9 Q1 squared over 0.5625. I'm going to multiply both sides by 0.5625. Okay, so that's going to give me worried I'm going to run out of space. So that's going to give me 0.1687. Oop, back here, 875 equals 9, e to the 9, q1 squared. I'm going to divide both sides by 9 e to the 9. Yeah, I'm close to running out of space. I'm going to get 1.875 e to the negative 11 equals q1 squared, and then I'm going to have to take the square root of this. Okay, and then math teachers would get so mad at me for doing this, but I'm going to go ahead and do it anyway. Q1, they don't like it when you draw arrows all over your paper. 4.33 times 10 to the negative 6 C. So this is going to be our charge for Q1 and our charge for Q2. Okay, because they're exactly the same. Don't forget to take that square root. Okay, a lot of students forget to do that, and then they get the wrong answer. So don't be that kid. Now let's see what's next. So this is Ohm's Law, and it's a pretty simple formula. It fits in the triangle, but we are going to use this a lot because you're going to need it in circuits in addition to just using Ohm's Law. And so what I've done here is I have 3 different Ohm's Law problems. And the reason I have these 3 different problems is because I want to show you the relationship between your R and your V, okay, and your current as well. So for this problem, basically we've got 3 different scenarios, and as we go, your current is going to get larger and larger, and you'll kind of see how it affects you. Okay, so we need to know the current, and your current is an I. That's the symbol for current, even though it's C. Current is the most confusing to me because the symbol for current is I, and then the units for current are amps, which doesn't make sense to me that there's all these different letters for current, but that's neither here nor there. So we need to find our current. It's going to be in amps. Our resistance is 2400, and this symbol means ohm. So it's 2400 ohms. Okay. And then volts is my favorite because the symbol for volts is volts. And another thing that they call this sometimes they call this the potential difference. So if they say like with a battery with a potential difference of 12 volts, that's your V. They just say potential difference sometimes. Okay, so our formula is R equals V over I. We can put that in the triangle. So we have V on the top, I on the bottom, and we'll have R over here. So we have I equals V over R. Our V is 12. Our R is 2400. And our I is a very, very small number. Okay. So this is just going to give you a very small shock, and you get 0.005 amps. Okay, it's not going to be huge. Maybe you guys have done this before. I know people who like wet their finger. They take one of those like 9-volt batteries, the square ones, and they wet their finger and put it on one end, and then they like touch the other end with their tongue. I wouldn't recommend this, and you get a little bit of shock, but it's not enough to like kill you or hurt you or anything like that. It's just, I don't know, people do it for fun. I would not recommend doing that, but I've seen people do it. So then let's do a different one. So now we have an R of 7,000, and we're putting a paper clip into a 100-volt socket, and we want to find a current. Okay. This purple I feel like is not easy to see. Let me see if I can find a lighter color. Okay. So we want to find the current. Our R is 7,000 and our volts are 110. Okay, same formula, V over I, and then V, I, R, I equals V over R. So then we have 110 over 7,000, and we get 0.0157 amps. Okay, so remember last time we had 0.00, so now we're a whole order of magnitude stronger. So this will give you a decent shock. I remember when I was a kid, I guess I wasn't thinking clearly. It's twice, I don't know why. And I stuck a magnet in an electric socket. I would not recommend doing that either. I guess today is like, let's talk about all the things we shouldn't do. So now this one, we've got, we still want to calculate the current, but we've got a 9-volt CD player and it's falling into a hot tub where you are, and your R is equal to 100. So your I, we don't know what that is. Your V is 9 volts and your R is 100 ohms. R equals V over I. Let's put this in our triangle. RVI. I equals V over R. And V is 9. R is 100. And we're going to get 0.09 amps. This is going to be hurtful. Okay. This is why we really suggest like not playing with electric things near a tub. Okay, or you're having your hair dryer plugged in or whatever near the tub. You really because your resistance is so low, it doesn't even have to be something that's very powerful to give you a pretty nice shock. Okay, so there's a little bit of safety lesson. So now let's discuss circuits. These are some symbols, some common symbols for a circuit. Just a straight line is going to be a wire. A switch is basically like 2 dots in a line, so it can be open or closed. A resistor is just a squiggly line, and it doesn't really matter how many squiggles you have. I don't really, I just kind of, I go like this. An ammeter is a circle with an A, a voltmeter is a circle with a V. A light bulb looks like this, but it can also look, sometimes you'll see like that. You'll see like these squiggles, and then you'll draw a circle around it, and that's your light bulb. So that's kind of how a circuit works, and we'll get a little more into it. Now, these are your formulas for a series circuit. Write these down, put them on your formula sheet. For a series circuit, to get the total resistance, you just add them all together. It's really nice and easy. And to get your total voltage, you just add them all together. And then the current is the same throughout a series circuit, and we'll see why in a second. But really make sure you have these written down, because it's going to be different for a parallel circuit, and you don't want to, they ask you for the total resistance of the series circuit. You don't want to use the parallel circuit formula, or you get the wrong answer. So here is a series circuit, and there's a couple things I want to show you. So basically, we're going to have our current is going to kind of go like this. Okay, so you can see the current. The reason the current's the same throughout the whole thing is there's only one branch, there's only one path for the current to take. So, if the current is something here, it's going to be the same there, because, it's taking the same path. There's nowhere else for it to go. Okay, so it's the same all the way around. Okay, And then let me see if this will show up on the block. Yeah, it kind of does. But I'll do another color just to be safe. Okay. So now let's say we want to calculate the total resistance. Okay, so this is a series circuit. So our R total is just going to be adding these up. So we have 12 plus 12 plus 8 plus 8, and then we'll get 40 ohms. And that's going to be our total resistance. And that's really all you have to do for a series circuit. It's nice and easy. Series circuits are my favorite to calculate resistance because they are so easy. Okay. Now, this is a little more complicated version of a series circuit. Basically, we've got a series circuit, but they want us to find some other things as well. Okay, so here's what we can do. So the first thing we know is we have all the information but the current for this one. So we can use this one to figure out the current. And so our current is just V over R, right? Because we're going to use that Ohm's Law formula. And so it's going to be 6 over 3, which is 2 amps. Okay, and that's our current for everything. Because remember, a series circuit has the same current the whole time. Okay, so now we've gone ahead and we've gotten our current. Okay, now our V2, the way we can calculate V2 is we're going to use our Ohm's Law formula, right? R equals V over I. This is the formula we're using the whole time. I'm just, I've already done the rearranging. I'm going to take my 2 amp current and I'm going to multiply that by my 2 ohm resistance, and I'm going to get a 4. So my V2 is 4 volts. Okay, now you can find V3. You can do 6 plus 4, and that's 10, and your total must be 12, and so 12 minus 2, or you can actually do the math. It doesn't matter. It doesn't matter to me. Okay, let's say we wanted to, I'm actually going to do it that way. So we've got 6 plus 4 is 10, and then we have 12 minus 10 is 2 volts. Okay, so now we can take that 2 volts that we have and our 2 ohms and find R3. Okay, so we've got V over I. Our V is 2, our I is 2, so our R3 is 1 ohm. Okay, and that's all we have to do for this one. So we just kind of take it one by one and always have something where, we've got 2 out of 3. That way we can keep going and finding the rest. Okay, so that's a series circuit. Now, parallel circuits are a little bit different. I think they're more difficult because you have to use fractions, but we can figure it out. So basically 1 over REQ is 1 over R1 plus 1 over R2 plus 1 over R3 and on and on. And then in a parallel circuit, you're going to have multiple currents. Okay, so R1 is going to have a current, R2 is going to have a current, R3 is going to have a current. And I'll show you why in a second. Okay, so here we go. Here is our parallel circuit. And here's why we have multiple currents, okay? Because our current can go here, or it can go here, or it can go here, okay? And then it all comes back around. They all end up at the back of the battery. Okay, so the way I like to think about these is you can think about kind of like a pie. So, this guy takes a slice, and this guy takes a slice, and then this guy takes a slice. You have to split it up, and then it comes back around. We've got the total pie, I guess, right here. And then that guy will take some, that guy will take some, that guy will take some. Okay. So if we want to calculate the total resistance of this circuit, They actually call that the equivalent resistances. 1 over EQ, or 1 over REQ equals 1 over 48 plus 1 over 16 plus 1 over 24. Okay, so then what I'm going to do is I'm going to just go ahead and I'm going to break these into fractions or into decimals because I don't like dealing with fractions. They're annoying. Okay, I'm going to add these together. Okay, now that is 1 over REQ equals that, right? That is not actually the equivalent resistance. Okay, the equivalent resistance is 1 divided by 0.126, which is 7.94. Stay. Okay, so if you get a really, really, really small equivalent resistance, you probably forgot the last step. So, just keep that in mind. So that's your total resistance. You can see it's a little more difficult than a series circuit, but it's not like the end of the world. So now let's do the same kind of thing. We've got this parallel circuit. Let's try and figure it out. Okay. So we have a 12-volt battery. Now, for a parallel circuit, the voltage is the same throughout the whole thing. Okay. So we can actually go ahead and we can actually write 12 volts here and 12 volts here. Okay. And that means we've got the voltage for each one, right? So then we could figure out our I1 and our I2. Okay. So current 1 is going to be V over R1. So that's going to be your 12 by 12. And this little symbol should be ohms. The thing I got it from didn't copy quite right. So that's going to be 1 amp. Okay, and then our I2 is V over R2, which is 12 over 6, which equals 2 amps. Okay, and then our I total is just going to be I1 plus I2. So that's going to be 3 amps. And then the last thing we need is our equivalent resistance. You can see I left that for the last because I don't like fractions. My numbers are just like, my letters are just going all over the place. So I'm going to do 1 over 12 plus 1 over 6. And that's going to be, I'm just going to put them in decimals again. Okay, so I'm going to have 1 over REQ equals 0.25, which gives us an REQ of 1 over 0.25, which gives us 4 ohms is our equivalent resistance. And another thing with parallel circuits is because of the way they calculate equivalent resistance, a way to know that you got the right equivalent resistance is it's going to be smaller than any of the single resistances. So you can see we had 12 and 6, and so 4 is smaller than both of those. So that lets me know that my answer is probably correct. Okay, so that's how you solve that kind of problem. Now we have something called complex circuits. And this is when we're going to have series and parallel circuits all in one. Okay, so that it just kind of ups the ante complicated wise, but it makes it kind of like a little puzzle. So they're not too bad. I think sometimes they can be fun. Because somebody told me it was like Sudoku. one of my students once. I've never played that, but that's what they said. Okay, so here's our circuit. And you can see we have these two series circuits, and we've got this parallel circuit. So what I'm going to do is I'm going to compress this parallel circuit, and I'm going to find the equivalent resistance for that parallel circuit. And then I'm going to have a new diagram that looks like this. And whatever I find the equivalent resistance is for that parallel circuit, I'm going to put that right here. Okay. So then I've got all of the same type, which makes it a little bit easier. So 1 over 10 plus 1 over 10 is 0.1 plus 0.1. 1 over REQ is 0.2. REQ equals 1 divided by 0.2, which is 5. Okay, so this is going to be 5 ohms then. And now that we've got this circuit, now we can go ahead and basically in step 2, we can find our R total, where now that it's all a series, we can just do 5 plus 8 plus 6 and be done with it. Okay, and they get 19 ohms. So that's our total resistance. So series circuit, you just want to basically find the parallel circuits, kind of compress those a little bit, find the equivalent resistance for those. And so then we've got the one circuit. And then once you've got it down to one full series circuit, and there's no more parallels, then you can find the total resistance. Okay, and then we're going to do one more, like this, where we're going to find all those different things that we were finding before in our circuit. Okay, so this is in ohms, this should be in ohms, and this should be in ohms. Okay, so let me see. The first thing I'm going to do is I'm going to take this part and I'm going to make it into a, I'm going to find the equivalent resistance. Okay, so 1 over REQ is 1 over 24 plus 1 over 12, which is 0.042 plus 0.083. So 1 over REQ and that's going to give me 8. Okay, so then I'm going to have a new circuit. I'm going to draw that here. I'm going to have 8 ohms here and 2 ohms here. Okay, so then my R total is just going to be 8 plus 2, which is 10. Okay, and then for my I can actually find my I total since we have a series circuit and the current is the same throughout the whole series circuit, right? Because it, it goes around like this. We can have I total equals V over R, and our volts are 30 over here, and our R is 8. Sorry, our R is 10. I was just looking at the one. Should be looking at my R total. So 10 over 30 over 10 is 3. So that's going to give me a 3 right here. I'm going to rewrite this in a darker green so you can see it. Okay. And that's also going to be R3 as well, right? Or I3. So that can go right there. Okay. Now, now that we've done that, we need to find our volts. And to me, I think the easiest way to do that is to find the volts of R3. Okay, so I'm gonna take a different color, and I'm gonna find the volts of R3. So that's gonna be R3 times I. My R3 is 2, and my I is 3. So my volts are 6. My math is not strong today. I'm gonna write this in red here so you can see it, even though I know I wrote it in yellow over there. I know yellow won't show up here. Okay, so now these two guys, the way a parallel circuit works is that both circuits or both resistors in the parallel circuit will have the same voltage. Okay, and if we have 30 volts as our total, and this resistor has 6, then our V1 and our V2 must be 30 minus 6. Okay, so 30 minus 6 is going to equal 24 volts, and that'll be the same for both. Because a parallel circuit, you know, they have the same voltage. Okay, so now we can find I1 and I2, which is the current for this guy and the current for this guy. Okay, so to find I1, we're going to take our V over R1. So we're going to take that 24 over 24, which is our R1, and we're going to get 1 amp. Okay, and then for I2, we're going to do V over R2, which is 24 over 12, which is going to give us 2 amps. Okay, now our I total is 3, right? And so basically when these two come together and they become this guy right here, they need to have the same amp as that 2 ohm resistor right there, which they do. 1 plus 2 is 3. Okay, so this tells us we've got the whole thing kind of done correctly. Okay, so that's how you do a complex circuit, how you find all of the voltage and the current and the resistance. You just kind of have to take it step by step and just, you know, kind of figure it out a little bit by a little bit. And that's why some people say it's like a puzzle. Okay, so now let's discuss magnetism. So this is our main formula for magnetism. It's a force equals Q, which is a charge, times the velocity of the particle times the magnetic field. And let me just write this for you. The others are probably familiar, but not this B. This is the magnetic field. And the units for magnetic field are Teslas, and abbreviated with a T. Okay, and then just so you have it here, the charge for a proton is plus 1.602 times 10 to the negative 19th. This should be like to the 19th, like this. And then the charge on an electron is exactly the same, but it's a negative. And that's not something you have to memorize either. Okay, so just, you know, they'll either give it to you or you can write it on your formula sheet. It doesn't matter to me. Okay, so if we were going to get a problem like this, it would look something like this one. So what do they say? They say, what is the force? So our force is going to be our F on a proton. That's telling you that it's a positive charge moving 3450 meters per second. That's our velocity at an angle of 35 degrees. That's our theta into the screen at 2A 1.75 magnetic field that points to the left. So I'm going to do the math for you, and then I'm going to kind of explain how to do this right-hand rule thing. Okay, so our force we don't know, but we do know it's in newtons. Our velocity is 3450. Our theta is 35 degrees. B is 1.75 T. And then our Q is 1.602 times 10 to the negative 19 C, and that's a positive Q. Okay, so our formula is F equals Q B V sine theta. And I think it was actually Q V B, but it doesn't really matter because they're all multiplied by each other. So we have 1.602. I'm going to write it like this because that's how I'm going to put my calculator, and it also is a little shorter. 1.75, 3450, and then sine 35. And I have all these parentheses here because when I put it in my calculator, I'm going to need to put all these parentheses in here in order to get the correct answer. I'm going to get 5.55 times 10 to the negative 16 newtons. And then we're going to have to find the direction for this force. Okay, so basically they've told us that it's moving 3450 at an angle 35 degrees into the screen. Okay, so let's say this is our hand. Okay, I'm not really a good hand drawer. This is our right hand, so you want to take your actual right hand, which means you have to put down your pencil, and you want to push, basically have your thumb pointing into the screen. Okay, so it's like my thumb is pointing into the screen, and that's my velocity. Okay, if my thumb is pointing into the screen, that's my velocity, and then it says the magnetic field is to the left, which is what you get with your hand, right? Because our fingers are pointing to the left, right? So then we need to see what's going on with our palm. And our palm, if you take your right hand and your thumb is pointing into the screen and your fingers are pointing to the left, that means your palm is facing upright. Okay, so this is like going like straight up. Okay, so your force is going to be 5.55 times 10 to the 16, negative 16 newtons up or upwards. Okay, so this is again, it's kind of hard to draw because I'm trying to draw something 3D on a two-dimensional surface, but you actually, to do these, you have to actually take your hand, put down your pencil, and do it. And I'm right-handed. I know a lot of us are right-handed. So for me, sometimes I want to try and do it with my left hand because I've got a pencil in my right hand. So the way I remember I'm using the right hand, besides the fact that it's not my left hand, but if I have to put down my pencil in order to do it, then I know that I'm using my right hand. Okay, so that's kind of how I do those kind of problems. Okay, so that is our little magnet problem. So we've gone through quite a few different types of problems from the electricity and magnetism unit. So hopefully those are helpful to you. There are even more videos of me like working through magnetism problems and working through Ohms Law and working through circuits and things like that in the course resource newsletter. If you go there, I've got videos like from previous semesters and things. So definitely check those out. And then I'm going to put this back up, our important dates, just so you guys, it's the last thing you see. And you have, basically these dates are our class for the rest of the semester. Like that's all we've got left. So we're pretty close to being done.